For you today, three students, Pete, Pat, and Tao, arrived to an instructor in office at the beginning of an office hour. The time that Pete, Pat, and Tao spend at an office hour is distributed exponentially, with means of 1 hour, 30 minutes, and 20 minutes, respectively. Assume that waiting times are random intervals and that students receive help simultaneously. Let Pete be a student number 1, Pat be a student number 2, and Tao be a student number 3. So we will use three-dimensional vector to describe the state of the instructor office, x1, x2, x3, where 1 means that the student is in office hour and 0 if not. So first of all, we want to define the transition rate matrix, the transition probability matrix, and the vector of waiting times, and the initial distribution of the process that describe the states of the instructor office at any time after the start of an office hour. Assume that the duration of an office hour is not limited. Okay, so first of all, let's look at the first section. So this is it's called the Q matrix, which will give us only the transition rate from each state, and on the diagonal will be the negative sum of all the rates. So here we see that moving from 1, 1, 1, where 1, 1, 1 is Pete, Tao, and Pat all in the same place, and we move to 0, 1, 1, meaning that Pete is not in the office hour, is with rate 1, and moving to 100, 101 is when Pat is not in the office hour, meaning rate of 2, and for what was his surname, for Tao to leave, it's rate of 1, it's rate of 3, because it was given to us that Tao will leave every 20 minutes on average. So here is the actual transition matrix, and now we want to write the probability transition matrix. So how do we do that? We'll need to look at this following formula, that the probability to move from each state to the other state given here is the flow from I to j, when I is not equal to j, divided by the flow of all the other states. Meaning here, let's say the probability to move from 1, 1, 1 to 0, 1, 1 will be 1 divided by 1 plus 2 plus 3, meaning 1 divided by 6. Remember that the items on the diagonal we do not consider in this summation, because this will be 0. And what will be the actual flow will be the sum of all the flow we already had. So we get this matrix, and we have this diagram. So if they ask you to draw it, we can just put this diagram in, really easy peasy. So this is all the three. This is 1 is not in there, which is Pete, and then Pat is not in there, and then Tao is also not in there. And here is Tao is not in there, and then Pete is not in there, and then no one is in there. So there's all the flow, look at that, and the rates. And now we will go to this, and they ask us also, what is the probability that Pete will leave first, followed by Pat, and then Tao? So to calculate this, we'll need to look here. We have Pete, Pat, and Tao. This is the order we want. So we have 1, 1, 1, and then 0, 1, 1, and then 0, 0, 1, and then 0, 0, 0. So we have 1 divided by 6 multiplied by 2 divided by 5 multiplied by 1. Why? Because we look at the probability that we go from here and then straight to here, and then from here going to here, and then from here to here. So how did we say we calculate this? We can look also at the transition matrix, but we can look at the following thing. We go from 1, 1 to 0, 1, 1, which is the probability of 1 divided by 6. And then from 0, 1, 1, which is the second row, we want to go to 0, 0, 1, which is 3 divided by 5. Okay, which is 2 divided by 5. Sorry, we want to go to which state? To 0, 0, 1. So 0, 0, 1 is 3 divided by 5. So I made a typo here. So it's 3 divided by 5. And then we get, this is 2, this is 10. So we go from this state to this state, and end. Wait, we want to go from 1, 1, 1, so we go to 0, 1, 1, which is 1 divided by 6, and then from 0, 1, 1, we want to go to 0, 0, 1. So maybe I wrote this table incorrectly, but to go from this to here, we will need 2 divided by 5, which is, it was the actual correct answer all before. So maybe I just did some mistakes in this table. So we'll look at this section anyway. And we'll look, so we have 1, 1, 1, and then we go to 0, 1, 1. And 0, 1, 1, the probability to go from 0, 1, 1 to 0, 0, 1 will be 2 divided by 2 plus 3. And then from 0, 0, 1 to go to 0, 0, 0, it's probability of 1. This is why I write 1. So it's 1 divided by 15. Okay, so now we want to know the instructor planned to drink a coffee immediately after an office hour, meaning that after all students have left an office. Assuming that Tao left first, what is the expected time from the moment of his departure until the instructor will get to drink coffee? So here it's classic problem of maximum between two exponential random variables. So they're independent. So we know that Tao left, so we have 1, 1, 0. And we want to know what is the expected time that the teacher will have to wait more. So in order to know that, we are going to look at the probability that both before time t, both Pete and Pat are leaving the office. So in order to do that, we look at this probability. Okay, so we have this probability. This is just from the exponential variable, just multiply both of them because we know they're independent of each other. And now I just multiply both of them, and I just organize it a little bit, so from this to this, and then I look at the derivative, so the density function. Now look at the density function, and we have this density function when I get the derivative. So now when I look at each one of the sections, and it's look really similar to already exponential random variable. So if we will look at that, we'll need to take for the expected value, we'll have to do an integral from 0 to infinity of t multiplied by dp divided by dt, so the derivative, and I just write it, and then we can look at all the sections look really the same except for constant. So here you have lambda y, but here you have lambda y plus lambda x, but look the same. So I did here the integral, like the general integral for 0 to infinity from t with t a and e to the power of minus at, and we get here 1 divided by a eventually. So it's really easy to calculate this integral, and then you just put all the number inside and you get it 1 divided by lambda y plus 1 divided by lambda x minus 1 divided by the sum of lambda y plus lambda x. So hope you like this video. Please like and subscribe. It was really long video for me and it's really late for me. And anyway, if you have any question, please leave them down below, and hopefully I will fix this table and I will re-upload it. Please like it so I will do it. Anyway, until next time guys, I'm out.